So let us going to understand the electron transport, that is the movement of electrons that will be happening within the light harvesting complexes of the photosystems. Now everything begins with a light harvesting complex which we call as LHC. Now we know that there are two light harvesting complex, each representing one photosystem. So this light harvesting complex is of the P680. That means its reaction center reacts to the 680 nanometers wavelength of light. So when sunlight of 680 nanometers, how much? 680 nanometers lands on the reaction center of P680, there will be a phenomena called as excitation of electrons. Excitation of electrons. So the electrons within the chlorophyll A, of which is present in the reaction center of P680, they absorb the sunlight of 680 nanometers wavelength. They get excited. What do you mean by excited? Excited means they're basically jumping from their original orbital to an orbital far away from the nucleus. Correct? So when that excitation happens, the excited electrons, we will just write them as star. So the excited electrons, they move from the reaction center to a electron acceptor. Now this electron acceptor is the primary electron acceptor, and in this case it is 𝗡𝗃. Right. Now the excited electrons from 𝗡𝗃, here they are still excited, right? They move to a electron transport system. Now this electron transport system, it consists of three sets of electron carriers. One is plastoquinone, another is cytochrome B6 and cytochrome F, and another one is plastocyanin. So three electron carriers that carry the electrons from 𝗡𝗃 to the next stage. And when these electrons are passing through this electron transport system, ADP is converted into ATP. So ATP is formed during this system, which is photosystem 1. Sorry, this is photosystem 2, PS2. Okay, so this is photosystem 2, where you are having the formation of ATP. Now by the time the electrons come out of the reaction, the plastocyanin or the electron transport system, these electrons, they have already reached the ground state. They've already reached the ground state, and from there they are going to go to the second LHC, that is P700. Okay, now when sunlight of 780 nanometers, let's take another color for this, when sunlight of 700 nanometers falls on the LHC, again you will have excited electrons, and these electrons, they go to the electron acceptor, which is an iron sulfur component. From there they go to another complex where NADP is converted into NADPH, and here the complex is the FNR complex. Okay, so in this way the electrons will be moving based on their excitation. And why are they getting excited? Because they are absorbing the light of that particular wavelength which gets them excited. At the same time, there is this water splitting reaction where the electrons that have split, that have come from the photolysis of water, they also enter into the P680 light harvesting system. So this is PS1, photosystem 1, and PS2. Now this is called as the Z scheme of electron transport, because if you see everything, the uphill, downhill, again uphill, it looks like an inverted Z. And the entire movement is based on the redox potential. See, here you have been given a redox potential with lower energy, higher energy. So when the electrons get excited, they reach a higher redox potential. As they keep moving towards the electron transport chains, and as they keep moving towards the P700, they slowly lose their redox potential, the energy, and their redox potential comes down. Again, when they take the sunlight, again they have an increased redox potential. So the entire electron movement is completely based on the redox potential, which is again based on the electron, the excitation of the electron. So we are going to discuss this in detail in the next video.